This is my robot arm project, and over the last few months, almost every major component has been upgraded. The spherical parallel manipulator now uses stronger servos for better performance and reliability. I also redesigned the gripper, replacing the original version with a much more capable design. And while the old cycloidal drive got the job done, it was clear the next step would require something more powerful. Time for a serious motor upgrade. For this build, I chose the CubeMars AK80-9, a compact robotic actuator that integrates a brushless motor, planetary gearbox, encoder, and driver into a single unit. Despite weighing less than half a kilogram, it can deliver up to 22 Newton-meters of peak torque through its 9-to-1 gearbox. Small, but far from weak. CubeMars provides dedicated control software. It allows real-time monitoring, parameter configuration, and switching between different control modes. Getting the actuator running was surprisingly straightforward. But that was never the real challenge. The real challenge was not making the motor move. It was deciding how it should be controlled. Because this project is not just about building a robot arm. It is about connecting two different worlds. On one side, I built an industrial control architecture. A virtual robot inside Unity generates motion commands. Those commands are sent over Modbus TCP to a PLC, and the PLC executes them in real time, controlling the actuator. This creates a deterministic control system that behaves like industrial automation. But that is only one way to control the system. On the other side, I implemented direct CAN bus control using a Raspberry Pi. No PLC, no industrial infrastructure, just direct communication with the actuator using Python. This gives full access to position, velocity, torque, and telemetry data in real time. Two completely different control architectures, one actuator, and a single system that can operate in both environments. This makes the platform flexible. Industrial engineers can integrate it into deterministic control systems. Robotics developers can work directly with affordable hardware. And both can explore the same underlying actuator capabilities. And now, both of these approaches converge in one place, the robot arm itself. Because the real question is no longer how the system is controlled. It is what happens when all of that torque is finally applied to a real mechanical joint. And that's where this series really begins.